Hey guys, welcome back to another video. If you want to resize your preview, hover your mouse between the preview area and the display options below. When you do this, your cursor will change to an up and down arrow. Simply click and drag up or down to another video. Adjust the preview size to resize your preview. Hover your mouse with the size of the actual recording. Start by confirming the source is selected. Hover your mouse over any of the red points around the preview. Then click and drag to resize. If you make a mistake or want to revert changes, press Ctrl plus Z to undo. To crop the recording, hold the Alt key between the sides. If you make a mistake or want to revert changes, press Ctrl plus Z to undo. To crop the recording, hold the Alt key between the sides. If you make a mistake or want to revert changes, press Ctrl plus Z to undo. To crop the recording, hold the Alt key.
Moly, is that just going to keep on repeating?
Between the sides. If you make a mistake or want to revert changes, press Ctrl plus Z to undo. To crop the recording, hold the Alt key.
Moly, is that just going to keep on repeating?
Let me make the audio real quick.
Between the sides. If you make a mistake or want to revert changes, press Ctrl plus Z to undo. To crop the recording, hold the Alt key.
Moly, is that just going to keep on repeating?
Let me make the audio real quick.
Between the sides. If you make a mistake or want to revert changes, press Ctrl plus Z.
Is that going to be better now? Okay. Could I add a source for video capture? Nice. Alright, can I put, what's YouTube, what's Studio Mode? Wait. Program, preview scene, program scene, and I guess when I make a change, it would, a transition into it, for sure? Yeah. Transition again. Mhm. This is still the video, but if I transition into it, oh, then quick transitions fade to black. That's cool. Hello. Hi, pretty.
Variables. Edit the system environment variables. Here or create a new desktop. Call this folder your folder now file. C/. C++ extension pack. We can close out of this extensions menu. Okay. Okay, we can close out of this extensions menu and go back to the Explorer window. For the CodeRunner extension, there's two settings I recommend enabling before we continue. Let's go to File, Preferences, Settings. We're going to look up CodeRunner. Check this checkbox of Clear Previous Output. That'll clear the output before we run each program. And then scroll down. Check Save File before run, so you don't have to manually save each time you want to run a program. And those are the two settings I would recommend for the CodeRunner extension. Next on our to-do list is to check to see if we have a C compiler already installed. To do that in VS Code, you can go to the Terminal tab. Go to New Terminal. Now the instructions are going to vary based on your operating system. Currently I'm running Windows. To check to see if you have a C compiler, using Windows you'll type gcc --version. And now we need to set the variable path. Let's locate that folder. It's within my C drive. msys64. Alright, ready to write our first C program. Within our C file, the first thing we're going to write is this statement. # include, then within angle brackets, stdio.h. This statement is a preprocessor directive. We're telling the compiler to include the standard input-output library. It contains a lot of useful functions for output and input. We need this header file in order to display text to the screen. Later on in this program, we need the main function in order for this program to well function. Here's how to create the main function. You'll type int, meaning integer. The entry point for a program is the main function. Main, add a set of parentheses, then a set of curly braces. Your program is not going to run without the main function. We can even try it. I'm going to cut it temporarily. To run your C program, go to this arrow and select Run Code. There's also a shortcut if you would like to use that too. Well, without the main function, we get this error message. Returned 1 X status. I'll paste the main function back in. Now we don't get that error message, and we do have an executable within our coding folder. Our program is running successfully, but it doesn't do anything. So, you need the main function in order for your program to, well, function. It's the entry point of your program. What you'll call commonly see at the end of the main function is this statement: return 0 semicolon. In the C programming language, the main function is expected to return an integer. It returns it to the operating system. This integer serves as an exit code. 0 indicates that the program ran successfully. A non-zero value typically indicates an error or problem of some kind. In older versions of C, such as C89 or C90, omitting this statement will lead to undefined behavior. But in later standards, you can omit the statement, but it's considered good practice to include this return statement just for backwards compatibility. We have a program, but it doesn't do anything, so let's print some text. The main function is the entry point of our program. Within the set of curly braces, we'll write some code that we want to print. To print some code, you can use the printf statement. Printf, parentheses, then a semicolon at the end. We end all our statements with a semicolon. It's kind of like the period at the end of a sentence in the English language. Whatever you would like to print to the screen, you're going to do so within quotes, double quotes. Think of a food you like. My first statement will be, I like pizza, exclamation point. And now, if we were to run this program, we can print this text. So let's run this code.
Smart.
And the output is, I like pizza. Let's add a second printf statement.
Okay, so like,
Printf, let's say, it's really good. Then be sure to include that semicolon at the end. Now we should have 2 lines of output. I like pizza, it's really good. One issue that we're running into is that we're displaying all of the text in one line. To move down to the next line, you can add a new line character, which is a / and an F. That's a new line character. Now our next line of output should be on the next line. I like pizza, it's really good. To print some text to the screen, you just type printf, then within quotes, add some text. Now we're going to discuss comments. To write a comment in C, add some text. Now we're going to discuss comment. To print some text to the screen, you just type printf, then within quotes, add some text. Now we're going to discuss comments. To write a comment in C, you use 2 forward slashes. Then you can write some text. For example, let's say, this is my first program. Comments won't display as output, and you can see that the text color is green. But that's a feature of VS Code. If I were to run this program, we don't see this comment. We still have our output, I like pizza, it's really good. Comments are useful as notes for yourself or for other developers. You can also write a multi-line comment. To start a multi-line comment, use a forward slash, then an asterisk. You'll have an asterisk, then a forward slash again, wherever the comment ends. We could say something like, this is also a comment. This won't display as output either. We still have, I like pizza, it's really good. Throughout the series, I'll be writing a lot of comments. And that's your first lesson in C. Now, you have a homework assignment. In the comments section down below, you have to write 2 comments and 2 printf statements. If you don't do your homework, I'm going to call the police, and they're going to come to your house and arrest printf statements. In the comments section down below, you have to write 2 comments and 2 printf statements. If you don't do your homework, I'm going to call the police, and they're going to come to your house and arrest you. And well, everybody, that is your first lesson in C programming.
I just had a lot of spaces.
Alright everybody, in this video I'm going to explain variables in the C programming language. You're probably used to variables back in middle school. A variable represents some value. Well, in programming we have something similar. A variable is a reusable container for a value. The variable...
Oh wait, we're moving already? Let's make it a 5 new folder. String. Let's do that story, right? Statements. And so we'll see that. And then we'll add a new footer. And we're gonna do variables. Sample. And then should add a sample print. Let's rename it. Rename. Print. And then bear with example in your file. Let's see. Okay. And that's supposed to say yeah. Okay. So let's do include. Yeah, it's this one. No, this one. Include. Is it studio thing? Why? So really just sort it out. And let's do this main. Is it? So you have to call the main as a variable kind of? Like function. Is that what that would be? Right there. And then let's make a comment like he has it. Variable equals a reusable container for value. And this says behaves as if it were the value it contains. So it's okay. Okay, let's go.
behaves as if it were the value it contains, but we do have the capability of storing more than just numbers. There's different data types. Let's begin with the data type of int, meaning integer. To create an integer variable, we will say int, meaning integer, then we need a unique name for this variable. Let's say we're working with ages. Let's say int age. we'll assign this variable a value using equals. So let's say that I'm 25. In the C programming language, we have to end each statement with a semicolon. So we can use this variable age, and it will behave as if it was the number 25. To display this variable, we can use that within a print statement. So printf, in the C programming language, to display a variable, we'll have to use a format specifier. Let's say we have a string of text, such as you are our variable age, years old. To insert a variable, I'm going to use a %sign for a format specifier. To display an integer, we'll use d, meaning decimal, years old. Following the string of text, I will add a comma, then the variable I would like to insert.
What the hell? Why do you do that for?
Use a format specifier. Let's say we have a string of text, such as you are our variable age, years old. To insert a variable, I'm going to use a %sign for a format specifier. To display.
So %sign to be a format specifier? I don't know, I should use a string because it's Python. So printf, then we're going to say you are. Dang, this one.
Displaying an integer, we'll use d, meaning decimal, years old. Following the string of text, I will add a comma, then the variable I would like to insert, my variable age. Let's give it a test run. You are...
What? What? Wait, how does it know that D is age? Oh, because I'm using it here. But what if I had two? What if I had, like, and fingers equals 10. Some people have more of that. They're weird. Then I had another one and say that fingers. Good. I need here. It won't get used. Data argument not used by format. So, what if and you have the fingers? If I use the twice, will it use? What? That's crazy. Wait, I don't even know. Can you even? I don't even know.
my variable age, which is 25 years old. So an int is a whole number, a whole integer. If I were to say 25.5, you know, like, it's my half birthday, well, we end up truncating that decimal portion because integers can't store decimals. To store...
Alright, so let me make a comment because he just said something I'm going to forget. So I keep this a comment. Integers not store decimal. Alright, it's better if I the other one. It's not this one. Back.
For a whole number, you can use an integer. Let's create another variable. Repetition is going to help us remember these steps. Another example of an integer could be a year. Int year. What year is it? I will say 2025. Then I'll create another printf statement. Printf. Let's say the year is... Wherever I'd like to insert a variable, I will use a format specifier, that %sign, then use d for decimal, comma, then my variable of year.
Okay, so print, so we're going to print the year. Why do you want to see the year? It is the year. Let's do the format thing. So it's, this is, keep the call this formatting thing. Formatting thing. I don't call it formatting thingy. And yes. Yeah, makes sense. That's year. And let's do a fashion real quick. Fashion. Year 2025.
The year is... Oh, and then let's be sure to add a new line character. Because I forgot to add that. New line. New line. That's better.
Why did he... Oh, I guess he's in...
You are 25 years old. The year is 2025. Let's create another. What's another good example of an integer? Perhaps a quantity. Maybe I'm buying just one product. You wouldn't have, you know, half a product, right? Quantities would be whole numbers, typically speaking. So let's say printf, you have ordered, we're inserting a variable, we'll leave that format specifier, %d. You have ordered our variable X items. We will insert our variable of quantity. Let's give it a test run. Oh, then a new line character. Okay, here's our variables. You are 25 years old. The year is 2025. You have ordered one X item, or items. And then we can change these values too. Maybe I would like to buy 2 items for the quantity. You have ordered 2 X items. Alright, so those are integers. They're just whole numbers. They don't have the capability of storing decimal portions. That's where the next data type is going to come in. To store a decimal portion, you can use a float, meaning floating point number. What's a good example of a number that contains a decimal? Perhaps a GPA, a grade point average. Float GPA. I will set this to...
He's just making a new thing. Variables? Well... For the print example, I'm just going to do that for variables. I'm going to have to rename this one to integers and integers. Why is this one called integers instead of integers like the one I made? Is it because this one is named? So you name this one to integers. Oh, okay. Integers. Yeah, it's not example. Example. No, it's gotta be main. Why does it have to be main? Why does it have to be main? Why does it have to be made? That's how I'm calling it. Main.c. Yeah, if main.0 it says it. What about double C? Let's put that real quick. Paste it here. And just double. What is this idea? Yeah, maybe it's gonna be. Let's just see. TV and include that. Huh. Wait, what is that? That just added math on its own. Ooh, to main. Where? Well, if I do still gonna work? Oh, I guess so. Oh, yeah. Is it doing this one? Oh, yeah, cool. Ah! Go back. I guess I can just leave it as main. Alright. Doubles. Why is it telling me something here? No, I didn't include that ever, so I don't know what it's saying.
2.5.
So, start this time. I'm going to doubles. So, what floats? So this one's going to float after average. I didn't want to play that much. Float. GPA equals 2.5. I'll do that. And we can go print F. We just check that. So print F. The average school. Is it still gonna be this one? There's school GPA. Yes, so we're gonna do this. That's on modifier. So it's called modifier. And yeah, no, I think I got this one. I have to do GPA. At the end. Format specifies tabular mass flow type fits and formats. What's the quick fix? Oh, wait, what is. Why is D not either? Like integer? I don't know. Oh man, it keeps going.
Hey, C's get degrees, right? Then to output this, I would use printf. Let's think of a sentence. Your GPA is, use a format specifier. Then for a floating point number, we're going to type F for floating point number. I'll add a new line character because I'm probably going to forget to do that later. And then I will display my variable of GPA. Your GPA is 2.5, and then a bunch of zeros after. C has a default behavior of displaying 6 digits after the decimal when working with floating point numbers. We do have the capability of changing that, but that's going to be a future video. You could add a dot and then a number to display a given amount of digits after. Your GPA is 2.5, but that's a whole other topic. We'll cover that in a future video. Another good example, but that's a whole lot of digits after. You could add a dot.
Or you can add the number of digits that you want to count. So I guess if I do 2, it'll be 2.50.
And then a number to display a given amount of digits after.
I see.
Your GPA is 2.5, but that's a whole other topic. We'll cover that in a future video. Another good example of a float could be a price. Float price equals 19.99, like $19.99. We will use printf. The price is, I'll pick a unit of currency. I'll pick American dollars, but pick whatever you would like. To insert a variable, we'll use that format specifier, the percent sign, then F for a floating point number. Then I'll add a new line character because I'm probably going to forget if I don't. The price is, we will insert our price variable. Let's see what we have. We have our GPA, 2.5. The price is $19.99. To display 2 digits after the decimal, you can use .2. More on that in a future video. A temperature would be a floating point number. Float. .2. More on that in a future video.
Well, you can't mention this.
A temperature would be a floating point number. Float. Temperature.
Wait. So, okay, so I was thinking it would treat this as like the decimal and add another point to follow the zeros, but it knows that this is so that way the decimal starts. And this is 2, so you have to specify 2 for it to not go past that. So you do 3, it'll go to 3 zeros instead. Okay.
Negative 10.1.
What the hell? You can use negative to code, I thought it would crash it. Okay. If I was a computer and you saw me numbers can go into the negative, it would be like flag. Temporary short equals, well, we're using Fahrenheit Celsius. I hope this is Fahrenheit. Wait, can Fahrenheit even go Celsius? No. Right? Average American here.
It's really cold outside. We'll use printf. Let's say the temperature is at a placeholder f for floating point number. Then I'll add a new line character. Then display our temperature variable. The temperature is negative 10.1. This can be Celsius or Fahrenheit. Let's add that. To add a degree symbol on Windows, hold Alt then type 0176. I'll say F for Fahrenheit. The temperature is negative 10.
I'm confused. What is it? What does it say? How is it in there? Like, this is this. Let me run this real quick. What? What? More conversion. Oh, I'm freaking stupid. I forgot to add the base argument for it. Like, what? How did he summon that out of his keyboard? He just casually has the temperature signs on his keyboard. Can I look that up? How to keyboard for temperature sign. Zero 179. 0179. So, how does he remember that? 09. Oh, right now. 0971. Is that right? 0176. Oh my god. I got it so wrong. 0176. 0176. 0176. That did not make it appear. Well, I felt a little light too down, even though it wasn't. Alt Shift 8. That's a lot more, Alt Shift 8. It's not really working, huh? Shift F. That should.
And 1 degrees Fahrenheit. Then you can set up.
And then let's add a decimal to the format specifier. Adding a decimal point like 0.1 tells the code to not go past that digit number once it goes into the decimal. Okay.
Precision if you would like. But we're not at that point yet. Alright, so those are floating point numbers. They're numbers, including a decimal portion. We only have the capability of storing 6 to 7 digits after the decimal. If you need more precision, such as if you're working with pi, you can use a different data type known as a double. Select with 7 digits after the decimal. We only have the capability of storing 6 numbers at that point yet. Alright, so those are floating point numbers. They're numbers, including a decimal portion. We only have the capability of storing 6 to 7 digits after the decimal. If you need more precision, such as if you're working with pi, you can use a different data type known as a double. So let's say double pi equals 3.1.
Alright, so I guess we're going into. I'm gonna have to rename this to float example, and then we're gonna actually go and new file in folder called doubles example, and then wait. Wait, new file. Doubles example. C. Because if I run this one, it should make the. This one, we can do thingy again. Include. What am I trying to include? Is that way? Yeah. Studio.h. And then we're gonna do int main. Double pi equals. Let's look that real quick. 10 digits. No, I'm gonna use the AI. And let's go to this. Hold on, let me count. I'll feel like counting actually gonna go to this. I just have to know that this is supposed to be handled, so more doubles, more foots can handle. And we can do print f. This is, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 digits of pi. And we can do this. And I'm guessing for this one would still follow the. Would it still follow the that modifier? Not what we're gonna find out. What are we gonna find out? Why is it not? Let's turn 0 real quick. Okay, so I'm missing everything character. Oh. That's why. So the formatter is still using float. Let's guess. Is it D? No, because D is decimal. Oh, wait, maybe it will work though because that's what tell me. Fits, quick fits. Change to F, but F is limiting itself to what? 1, 2, 3, 4, 5, 6. And I'm guessing that CMOS that this motor 1, 2, 3, 4, 5, 6. Yeah. Let's limit. There it goes. Let's add that thing. Is that here? Floats can only go to 6 digits in a specific number. If you wish to go past the 6 digits, use the double specify a double. What would you call it? A double variable? No, that's not how you would say it.
1, 1, 5, 9. Then I don't know the rest, so I have to look them up. So with doubles, you can store 15 to 16 digits after the decimal.
15 to 16.
And then to display it.
After decimal. Wait, 15 to 16. Maybe this one has 17. So let's do that. That's not why this is 15 to pi. So that's what I just said. Doubles. Doubles and store up to 15 to 16 digits after the decimal.
Double, we'll use printf. Let's just say the value of pi is, use the format specifier, then type lf, meaning long float. Then we will display our variable pi. Now again, the default behavior of C is to display 6 digits after the decimal.
Oh, so
Next on our to-do list.
C is not the behavior. You know what? Oh, what the hell, did I go back like 20 million years on this thing? This is Stephen Man shopping colorable.
Alright everybody, in this video I'm going to explain variables. Yo, hey everybody, in this video I got covered deep. Yeah. Great talk. Let's say we have a letter grade. A type F. A deep. Is would another good example. I do an not student Bitcoin that diffuse point.
Okay. So, one float number.
Followed by the amount of digits you would want to display. Let's say 15.
Yeah, 15 for that one time. So, none of these are that. So, normal behavior. So let me look up the reason why would you use. Why would one use a float instead of oh, okay. So it's not like in store less. It's just less precise, I guess. Like, what if I was to, I don't know, what if I was to like print f this, like that. This is 15 digits of pi using float, and then we did operator, not f. Let's do float at 2 equals this. Let's do 5 2. Keep flipping on the keyboard. Oh, that's weird. So floats to so less. How many digits after some point can hold it? I usually have over, so let me double check before I go ahead for that. Let's know why it's presented internally as well as okay, so I read about it as a marker of 15 as a so when I use the numbers as one, it's just Somebody said. Okay. So it's something that's out of my league right now. I think that's how I'm gonna write it. Girlfriend. Low sticky search. What's sticky search? So let's go and go. You want the summer maybe? I found you left to sign. Let's go and go. You want the summer maybe? Right about where you left it. Is that what I said? That was song was. You know, for some reason, I thought this song was from Steven Universe. Steven Universe. That's from the garden. For real? So was it played with this song? Cause
let's go to the garden. You'll find something waiting right there where you left it, lying upside down. When you finally find it, you'll see how it's faded. The underside is lighter when things take.
is that from the original movie? I don't know. Okay, a little bit you're kinda. You should recognize that it was from it. Oh, I.
Another example could be Euler's number. This I gotta look up.
Alright. What the hell? Why is he doing E? Okay, hold on. Let me write my comments before I. Normal behavior. C is to only give 5 assist. There's no basis. That's why they're a little different. To show as use float
I'll just copy this.
What is E? Why did they call it irrational numbers here? No, that one's a double E. Oh, that's perfect. Is that okay? Let's do that. Let's do E. I don't need this to print out like that. Everything stays. Like, yeah, here it's not lines like this one here. Format. The format is same. What do the lines doing?
The value of E is our variable E. Oh, then add a new line character. The value of pi is 3.14 and some change. The value of E is 2.7 and some change. If you have a decimal number that needs high precision, you can use a double. In this series, we'll probably not be working with doubles too often. We'll stick with floats. But at this level, you should still be aware of the existence of doubles. With variables, you can store more than just numbers, you can store characters. Another data type is char, meaning character. Let's say we have a letter grade, like what grade did you get on the exam? When working with characters, you need to use a set of single quotes. Let's say we got an A on the exam. That's our grade.
Everything stays. So, character, grade. So this is going to store strings, basically. I'm going to show the.
Then to display this, let's use printf. Your grade is format specifier, then C, meaning character. Then I'll add a new line. Let's display our grade. Your grade is A. Or if I failed, this could be an F. Your grade is F.
Ooh. I see. I wonder how you can make like a list, like in Python. And then from that list, you would grab the letter grade, and it would like print out depending on the percentage that the person got. So like, if your percentage is below, well, it's 64, is it for an F? Below 60, there's so I don't know, grade systems are really different. Below 60, print your grade half. And yeah, let's do that. Delete this. Add a line break. And let's. Input file main. I thought. Alright, put this in here. And copy. So I'll make sure that so that's just okay.
Let's think of another example. Perhaps a symbol. Char symbol.
Alright. Let's do this real quick. So let me just add okay. I just need that modifier. This one. This modifier is C. Can't you just plug in? The there, why can't you just
Equals, then within quotes, pick a symbol. I will pick, let's say, exclamation point.
Oh, why did I change colors? I like it, they change colors. Page time. What am I doing?
That's the first thing that came to mind. Let's print our symbol. What can we say? I can't really think of anything, so let's say your favorite symbol is %C followed by our symbol. Your favorite symbol is an exclamation point. What about currency?
Your favorite symbol is just the matter symbol.
Char currency equals, pick a unit of currency, I'll pick American dollars. Printf, the currency is %C to display a character. Then we will display our currency variable. The currency is dollars, American dollars. Alright, those are chars. They store a single character. If you've programmed in a different language before, you're probably familiar with strings. Well, in C we don't have strings. In other languages, a string is a series of characters, such as a name. In the C programming language, we use an array of characters to represent a string. So, to store more than one...
There's no strings. Strings. Like in
one character, we can use char again, because we're working with characters. Think of a variable name, such as name. Then add a set of straight brackets. This is an array. An array can store more than one values.
Wait. Was it less than or less than right? Just look that up. I'll look that up later because I have an additional recency. I'm just trying to move up. Array. Table. Everything stays right where you left it. Everything stays. You still use char, but name is different. So this is gonna use different. Oh, just because this is first and
So to say, we will set this equal to, then use a set of double quotes. So now we can store more than one character. Why don't you type in your name? I'll use my YouTube channel name. Alright, then to print our string, well, our array of characters, technically, we'll say hello, format specifier, then S, meaning string.
strings. This should be enough. That's what I should do because it's going to be yeah.
New line. We will display our name. Hello, whatever your name is, whatever you typed here. With our array of characters, also known as a string in other languages, you can store more than one character. And again, they do have to be within double quotes. So what's another example of an array of characters? Perhaps
That's fine.
Types of food. The name of a food. So, char, food, straight brackets. Think of a food you'd like. I'll say pizza. Printf. Let's say your favorite food is format specifier S because we're displaying a string. Food. And I'm forgetting that new line. Hello, Brocode. Your favorite food is pizza. What about an email? Char, email, straight brackets. Equals, then within double quotes. I'm gonna say fake. Now with strings, you can include numbers, but they're treated as characters rather than numeric values. So we can't use them with any sort of math in the future. We have a character representation of the numbers 1, 2, 3. Then I'll add.
Razor bands, fried. So make it email. Characters, email.
An extension of @gmail.com. I don't want to give you guys my real email because some of you guys are weird. No offense.
No offense taken.
Your email is %s. I'll add a new line. Email. Hello, Brocode. Your favorite food is pizza. Your email is fake123@gmail.com. One last data type we're going to cover is bool, meaning boolean. Booleans are either true or false, but to work with booleans, we have to include this header file. At the top, we'll include std bool.
What? Hold on, you can't just say ST again, expect me not to. High reaction. Oh, let me stop. Entiendes? What are we gonna code right now?
Dot. Inst, we have to include this header file.
Booleans.
At the top, we'll include std.bool.h, meaning standard boolean. And this is a header file. To create a boolean,
So I'm trying to read this again. So let's include the header, which is s2 h, and also let's include what's this one? STDIL. Oh, STD stands for something. What does STD stand for? Studio? Information. What does STD stand for? STD Booleans. Why does Booleans have their own library? Why can they go with another library? It's from, but I don't understand it just as a library.
boolean variable, we'll type bool. Bools are binary. They're either true or false. True means 1, false means 0. There's only 2 possible values. This could be good if determining if somebody is online, for example. We'll create a variable of is online. They're either online or they're offline. So let's say that this is true. So true also corresponds to the number 1. That's also valid. Or if somebody was offline, this could be false. This also corresponds to the number 0.
Alright, let me. This, the booleans are actually going to mess me up. I've never really understood booleans. So let's do. Booleans store. Star true or false values. 1 equals true and 0 for the end there.
Zero. We tend to use booleans more internally within a program, such as when working with if statements, but you should still be familiar with them at this level. If I was to display a boolean variable, this is what it would look like. So I'm just going to use the format specifier, %d. We will display is online. This would give me the number 1. 1 also means true. If somebody were offline, let's set that to be false. This would be 0. With booleans, we tend to not display them directly using print. You would more likely see them be used internally within a program, such as within an if statement. If statements are a future topic, but I just want to give you a quick demonstration. You would type if, a set of parentheses, a set of curly braces. If is on.
Who is it at the top one? So if this online equals false, is that anything?
Online if this value is true or 1. Or do something such as you are online.
So it's just normally accepted as. Playing this part and this part.
Or we can do something else, using an else statement. Printf you are
I keep forgetting. Message this to false. See.
are offline. Let's give it a test run. Our boolean of is online is true. Since this is true, we would print you are online. The number 1 can also represent true. You are online. Or if this were false, well then we would execute this code. You are offline. False also corresponds with 0. You are offline. However, as humans, using true or false is more understandable to us. By looking at this code, we may not know what 1 means, but true or false makes more sense. Okay, let's do another example. Let's say, is student. I will set that to be true. If is student, if that's true, you are a student.
the reason why I'm typing it though is so I can get the muscle memory. Why do we use? Oh, that makes sense because it's the 1 and the 0, so there's no decimal point. Okay, got it. Girlfriend. She's not out of class yet. Alright.
Else you are not a student. Maybe you're alumni. Forgetting that semicolon. You are a student. If this were false, then you're not a student. One last example. Boole forced sale is something for sale. I'll set that to be false. If for sale, that item is for sale. Else,
Okay, first cell is strong. Right. This. And this. First. Else. Right. Time. And then we can do shuffle this one. Make sure that one. This one. This.
That item is not for sale. That item is not for sale. If it were true, then the item is for sale. So booleans are either true or false. True also means 1, false also means 0. But that's less readable to a human. So to work with booleans, just include this header file. Alright everybody, so in summary, variables are reusable containers for a value. A variable behaves as if it were the value it contains. Integers store whole numbers. They tend to be
Because this boolean here. Int float double int float character double int float character double. Is there one per word? Because there's 6 words in hello. I am back. Right. That should be.
Before bytes, at least in modern systems. Floating point booleans and a boolean in the comment section below. Those are this video. I gotta cover format specifiers.
Alright, that's that. That's gonna get this today. Alright, let me show my girlfriend. Sure, just so that's so that's a shit right here. Where's the actual words? So I just finished. I just finished going through the first part of the coding video, and this is for the coding language C, which is why this is not Pi. So I went through how to write print. Don't really like this word format. It's just like the coding thing. But wrote this. It's pretty similar to Python. Just print numbers or like data type. Just word pairs. So here's the list of different types that I went through. I went through int. I went through floats, doubles, characters, booleans, and arrays. The other things are like text thingies that hold what the code is. I'm not sure if it looks weird this way. But yeah, I wrote different ones. If I do zoom out, you can see like everything. Yeah, I don't know.
Is 60% water. So when someone asks, what about really evaporating clogged
Oh shoot! I forgot to end the stream. Yo, that's when the motherfuckers be fucking. They forget to end the stream. Let me